Hello, STEM people. So, we are continuing to talk about systems of linear equations with context. So, here we got a group of students. Actually, just pause the video and read it to yourselves, please. Hopefully, you paused and read it. And we have to determine the amount of small cars. And they told me that's X. And also the amount of large cars, which is Y. So the variables are already defined for me. So I don't have to write a separate sentence that says let x equal the amount of small cars. They told me that x is the amount of small cars, and they want me to find x. Now also realize that x is not going to be 2.5 because the group of college students can't have 2.5 small cars. All these answers have to be integers, non-negative integers. X can't be -2 either. How can you have -2 small cars? Well, you got small cars that can hold 4 people, large cars can hold 6 people. And then they rented 2 more large cars than small cars. So I've got a comparison of size, 2 boxes. One of these represents large cars, one of these represents small cars. They rented 2 more large cars than small cars. So more large cars than small ones. And Y represents the amount of large cars. So this tall column must be the amount of large cars that they rented, which is more than the amount of small cars that they rented. So Y is bigger than X. But I don't want an inequality, I want an equality. I know that they rented exactly 2 more small cars than they did large cars. I'm sorry, 2 more large cars than they did small cars. So if I take the number of small cars and if I add 2, then they will be identical. So I have my equation. The amount of large cars is the same as the amount of small cars plus 2. And I would graph that. So since it's already in graphing form, it's an mx plus b form. I just go to right here and do my best to graph it. Something like that. So there's y equals x plus 2. The y-intercept was 2, and the slope is 1, so up 1 over 1, up 1 over 1. And the other graph was, the other relationship was they went with 72 people. Remember, the small cars hold 4, so that's like saying 4 per car. And if you're saying the word per, you're probably going to multiply. So 4 people per small car, 6 people per large car. So that is 4 times x plus 6 times y equals 72. These are all the people that went in small cars plus all the people that went in large cars equals all the people in total. And this is hard to graph right away. So we're going to solve for y, which means I would subtract 4x and I would divide by 6 and I get -2/3 x plus 12. So I get to graph again. And my y-intercept is 12 and my slope is -2/3. So I go down 2 over 3. And then extend that line. Let's see here. And there it is. So here is the equation. They have one ordered pair in common, and that is the ordered pair 6, 8, it looks like. Does it look like 6, 8 to you? To the right, 6, up 8. What does that mean? 6, 8 is not an answer that's going to help us. 6, 8. Remember, these are college kids. We're going on a trip. What does 6, 8 mean? 6 is x, which is the amount of small cars. 8 is y, which is the amount of large cars. So the group took 6 small cars and 8 large cars. Notice that they took 2 more large cars than they did small cars, and 4 people in these 6 cars, that's 24 people. 6 people in the large car, so that's 48, and if you add them up, you get 72. And then let's see here. One of them was y. So to do it on Delta Math, click twice to plot a line. That first one was, y equals x plus 2. So making sure that the slope is positive 1. The other one was negative 2/3 x plus 12. So the 12 is the y-intercept down to over 3. And the intersection is 6 comma 8. So there were how many small cars? 6 small cars. 8 large cars. Submit my answer. Cross my fingers. Yes. For a second example, we have this. Please pause the video and read this to yourself. Well, it's about a paper company, and I always skip, after I read it once, I look again at what is being asked. Determine. So find out the amount of small boxes, and we're going to call that X. So again, we don't have to label our X's. They label them for me. Label our variables, I mean. And then the number of large boxes, which is Y. Okay, so if X probably isn't again 2.5, because how could I have 2.5 boxes? X could be 100 because I could have 100 boxes, but X can't be negative. I can't have a negative amount of boxes. What do I know about these boxes? Well, the small boxes contain 8 cubic feet. The large boxes, 16 cubic feet. There were 15 boxes in total, and all the volume, the combined volume, is 160 cubic feet. So how am I going to get two equations here? Well, first of all, the total volume is 160 cubic feet. Every small box has 8 cubic feet, and every large box has 16. And I don't know how many small boxes there were. That's why it's X. But if I take 8 times X, that will tell me all of the volume that these small boxes are bringing in. And if I add that to 16Y, that will tell me all of the volume that all the large boxes are bringing in. And adding that up should be the total volume, 160. So I call this the volume equation. You've got volume plus volume of the small boxes plus volume of the large boxes is the total volume. That's one equation. What about the other one? Well, the only other number identified in this whole paragraph is the number 15. A total of 15 boxes. Remember a minute ago when I said X could be 100 because there could be 100 boxes? Well, that can't be true because there's a total of 15 boxes. So I could have 14 small boxes. That would mean one large box. Or I could have 8 small boxes, but that means 7 large boxes because the total is 15. So that is just X plus Y is 15. This equation will be very easy for you to find if you really know and believe that X is the amount of small boxes and Y is the amount of large boxes. So there's a total of 15 boxes. So X plus Y is 15. So you can call that the amount equation. And then we have to graph these. Well, we're going to graph in mx plus b form. So we're going to convert both of these to y equals mx plus b. Starting with the second one, this is a one-step problem. You just subtract x on both sides and you get y equals negative x plus 15. So I got a y-intercept of 15, slope of negative 1. The slope is not negative 1x. The slope is a number. The slope is negative 1 here. The other equation is 8x plus 16y equals 160. I want to solve for y, so I subtract 8x. I divide by 16, divide everything by 16. So this negative 8 becomes negative 1/2, and 160 becomes 10. Here the slope is negative 1/2. And now I graph. Let's graph with purple. The first one is a starting y-intercept of 15 and a slope of negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. Bam. The other one has a slope of 10 and a y-intercept of 10, but a slope of negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And there I've solved it graphically, but you have to identify what the answer is. And it looks like the answer is 10/5, the ordered pair 10/5, which is totally meaningless unless you tell me what that means. What does 10/5 mean? 10 is the X, 5 is the Y. X is the amount of small boxes. So they must have shipped 10 small boxes and 5 large boxes. They shipped 10 small boxes and 5 large boxes. It's usually it's if the problem is posed in words, you should answer in words. So the problem was a paragraph, which was 4 or sentences or so. So I answer in a sentence. And notice, of course, there are 15 boxes in total, but the volume also checks out. So remember, it's 8 cubic feet per small box, and I had 10 small boxes. So that's all the small boxes account for 80 cubic feet. And the large boxes were 16 cubic feet. And 16 times 5 is 80. So both the small boxes and the large boxes contributed 80 cubic feet. That's a total of 160 cubic feet. And then we would graph this on Desmos. So that first one was, I forget already, 15. 15 was the y-intercept, and the slope was -1. So down 1 over 1, down 1 over 1. The second one had a y-intercept of 12, I think. No, 10. And its slope was -1/2. And there they are. They intersect at 10, 5. There were 10 small boxes and 5 large boxes.